everybody. Welcome to the Dallas chapter of FileMaker Pro user group. I'm Taylor Sharp. I'm co-chapter coordinators with Fred Craven and Greg Price. We're glad to have everybody here for our monthly meeting, first Friday of the month at noontime or lunchtime. We get started about 11:15, and we're glad to be here. We thank the Harmonic Data people for hosting us. We appreciate this location and getting all the multimedia done. Okay, for announcements, the first big announcement, well, I mean, there's the announcement that Chris is getting married shortly, but skipping that one, the next biggest announcement is that we have Pause on Air next week. So those of you that are not participating in wedding events and things like that over this next week might be joining us in Clayton, Georgia, Daharam Retreat Center. We're going to do the Pause on Air. I think this is like the third time that's been at this location. And basically, it's kind of the unconference. If you've ever been to Engage or DevCon, that's a very formal type conference, and this is a very informal. And in fact, a couple of years ago, we did it part of the time without any electricity, and that was entertaining. So, but it's kind of a fun conference that's all small groups. When you break up into little groups, most of the groups that you're going to be meeting with have like, 8 or 10 people in them. So it's nothing like Engage. So if you don't like big groups and feel uncomfortable at Engage, try a Pause on Air, next year or something in the future. It tends to be very technical people and people that are actual FileMaker developers. So it's not like for people who are like selling FileMaker or something like that. So it's, and it tends to not only be intermediate to advanced users. So. But speaking of Engage, that's the annual FileMaker Developers Conference is coming March, 7th, 8th, something like that, 2025. The registration is now open. I think the early bird registration saves you $100 or something is available right now. So if you want to save a little bit of money, jump on that registration and save some money. If you submitted speaker applications, I've heard from a lot of people that got rejected and several people that haven't heard anything yet. So if you haven't heard anything back from Julie, you might be on the list, but never know. They haven't let people know who are the speakers. Engage will be down in Austin, Texas. I hope many of you can be there and join us, and maybe we can even talk Dennis into coming down from Denver. Come on, Dennis. Anyway, it should be a good conference. Yes, Ralph Batista, El Presidente of Ronel Data from Houston, Texas. He's here visiting us today. Glad to have you, one of our out-of-town visitors. So he runs the Houston user group, and so we're going to hear about Square API stuff. So yes, that'll be useful. And I haven't actually done Square, so I'm going to learn something then. Thank you, Ralph. I will also give a long-distance award to Gerard Beutler for coming here all the way from Florida. He actually has relatives in Texas, so he didn't come here just for this, but we are super glad he is joining us all the way from Florida.
All right, welcome everybody. Glad to have you here. I'm really excited about today, in part because I am not speaking. I was going to speak, and life got busy for a variety of reasons you may or may not already be aware of. And so instead, a couple guys from my team volunteered this topic, and we had Lynette whip up some fresh art. We had the other art ready to go, still waiting. When we do talk about FileMaker and accounting, we will do that topic, just not this month. So instead, sync at scale. I want to give you just a tiny bit of background about what this is, what we're talking about. This is for one of our customers that we built a system that originally I thought should be a native app, right? Really an iPad app to be specific. And that's because of the request, kind of the mandate from the customer, was to have something that an executive could use to make a series of decisions that were being made presently on a big stack of PDF printed pieces of paper. So we'd generate a PDF, we'd print it out. It'd be many, many pages long, and an executive would make 300 to 400 decisions every day off those PDFs. And for a system that otherwise was almost entirely digital, this seemed like a logical thing to improve. And so that project finally got greenlit. But the customer didn't want a native application. It really wasn't a question of cost in this case. Sometimes when we're talking to a customer, to try to get over that entry hurdle on a native app can just simply be, there's just not that much money, right? That can be an issue. But that really wasn't the case in this instance. In this instance, it was that the customer, first of all, wasn't sure about an iOS app. They wanted an Android as well. Well, that certainly does increase cost, right? If we're going to do a cross-platform application, we have to use either fundamentally different technologies or some kind of a stack like React to do it cross-platform. But the real concern was, how do I support this? So I've got my executive who we're trying to build a really simple appy thing, and if you were to see it, you would look at it and say it looks like an iPad app, right? Because kind of the mandate of what they're doing is very straightforward. It's data over and over, decision over and over, yes, no, change this, kinds of things with really the information needed to make the right decision surfaced to that executive, right? So for that context, our customer felt like they would have a hard time supporting that native app, but they didn't feel like they'd have a hard time supporting a FileMaker application. And so that is the background story for what these guys are going to show you. And I just want you to keep that in mind when you see what you're looking at. So this is our effort to build a non-native mobile app in FileMaker that kind of works like a native mobile app would.
So sync at scale. So this is the solution was for really their executive management to approve large numbers of expenses from the bookkeeping department. That's kind of the general context of where we're at. So first of all, considerations for sync. First and foremost, don't do it if you don't have to. There were several years ago at a DevCon, I went to a presentation by Dawn Hetty at Soliant about sync. And I was like, this is going to be great. She's going to tell us just do this simple thing and flip this switch and it'll be easy. And her first point was, don't do it if you don't have to, because it's hard and messy. And unless it's actually solving a needed use case, don't do it. And then if you have to do it, one of the things to consider is how much data are you having to move back and forth? And then do you just need to read data, or do you also need to write data back to the server? So I want to talk about why we decided on offline sync. As Steve mentioned, the customer's current process was reviewing paper, and lots of paper. So that creates delay, but also for each of the things they were having to review against someone's budget to decide, is this within budget? Do we want to pay this, et cetera? They have to, outside of the paper, go look up the status of that person's budget for all of these individual pending expenses. And that is a lot of manual work. The budget information that they kind of care about kind of falls into a few different buckets. So there's, the budget line itself, how much money has currently been spent against that budget line for the fiscal year, how much has been approved but not yet paid. So kind of, what is the number of dollars that are waiting to be printed on checks and mailed out, or ACH'd, or whatever the case may be. And then there's the total of the kind of pending lines that need approval. So there's those kind of 3 buckets of dollars for each budget line for each person who has these things. So the primary problem, why it was difficult to do this on the hosted FileMaker solution, is all of this data is aggregated from different tables all throughout the system, and loading that data to make a quick payment decision is just too slow in FileMaker because of just the vast amount of related data that you're going to have to pull. There's just no way that it would be faster than scanning through a piece of paper. The solution was, well, let's localize the data so that way these ongoing database calls aren't needed. Let's get everything that we need all at once, and then you can skim through that, and you only have to talk back to the database once all those decisions are made. One of the advantages of this that we kind of discovered during development is all these different calculations that we have in the local app that we're able to just have as unstored calcs without any noticeable performance hit. So we've got calcs doing sums and counts and percentages, and unstored calcs that are used to graph different things and chart positions on budgets and all of this stuff, and all of that is unstored. And it's super quick because it's all local in that FileMaker file on that person's computer. Things that you just could not do on a hosted solution for performance reasons. The first big piece was the amount of planning that we did in it, and this is just some excerpts from a design document that actually Heather and John created. And so, we wrote out an extensive list of user stories of, what does this app need to do? What does the user need to be able to accomplish with this? So we had a very clear picture of what we were building and what we weren't. We had, workflow diagrams and interface flows to understand, navigation throughout the application. What's not pictured here, but we had fully spec'd out Figma prototypes and wireframes, so we had a very clear idea of what this thing was going to look like. And then that third document, it's kind of small to read, but that's a list of all of the data requirements that the local app would need. So before we ever started any development, we went through and decided here's the minimum number of data points that the app needs to do its job. We don't need all of the data from the server, just a very small amount of it from a select number of tables, and even within those tables, sometimes only 2, 3, maybe 5 fields. So we had all of that kind of planned out. So now I kind of want to talk about the scope of the problem, so the amount of data that we're having to move around. So first we have the expense lines themselves that are being approved, and there's roughly about 10,000 of those a week that they're having to approve. So maybe 2,000 a day, but maybe management isn't approving them on a daily basis. Maybe they're just doing it once or twice a week. There's roughly 30,000 payees in the system that the local app needs to be aware of. There are the individuals who have these budgets are called participants, and there's roughly about 2,000 of those. And then the big one, budget lines, there are roughly 100,000 of those.
Only.
Only across those 2,000 participants. So we're looking at 140,000 records or so that need to be localized. That is a massive amount of data. That's I think sync at a scale that we hadn't done before. I hadn't, Brian hadn't. So it was an interesting challenge. So first I want to talk through the approaches that we went through to read all of the data, starting with all of that budget line information. So we decided we're going to pull that budget line information from MySQL. The reason for that is we have a pre-existing process that runs on a nightly basis that rolls up all of the current spend status of each of those individual budget lines. However, there's no table in MySQL or FileMaker for that matter that actually gives us what we need. What we needed for this app was a cross-section of different things. So we just wrote a MySQL view off of the MySQL data. And there's that select statement for the view. If you care, you probably don't, but we just wrote a view. The result of that is it's very performant. MySQL being a SQL database and the engine that it's written on, it can return those 80 to 100,000 quote unquote records, within a second or so. It's just very, very fast. And then for everything else, all of the other data points that we needed, we're just going to pull those from the hosted FileMaker solution. So how do you get these? Well, obviously you use a RESTful API because we're modern and that's how you do things, right? You just use a RESTful API. And so our plan was get the record data back as JSON in good modern fashion, loop through that JSON response and write out local records. And that would be wonderful. That's just how I thought we were going to do it. And this worked great in testing small record sets as we were getting the API calls ironed out and everything. And then we removed those test limits to actually pull in the amount of data that we needed. And it was abysmally slow. Atrociously slow. Slow as in, it would take hours to write the data into the local FileMaker file.
Is that status bar even moving?
Yeah. For me, I would say that that level of performance is a complete non-starter. If I click sync, I don't want to have to wait hours to start my job. That's...
Just start it before you go to bed.
Yeah, exactly. Steve said, just start it before you go to bed.
Like the dishwasher.
Yeah. Yeah. So we had to come up with another solution and rewrite kind of the sync engine that we had written. Our next attempt was based on the understanding that FileMaker imports records a whole lot faster than it writes them one at a time. So we took a couple hours and built a virtual list table and wrote some scripting to just import into the local tables from that virtual list table. So we would have the JSON response in global variables, and then the virtual list table would translate that, and then we just import it. And that was going to solve everything for us. It was going to be so much faster. Except it was still abysmally slow. And so we discovered that the problem is, for some of these things, the API JSON response that we were getting was a 10 megabyte blob of text. That is a massive amount of text. And FileMaker's JSON functions they just choke at that size. They're not performant enough to deal with something like that. Probably one of the main reasons for that is whichever JSON function you go for, one of the built-in functions, FileMaker has to scan through that entire object, in part to verify that it's a valid JSON object, before it ever tries to give you the thing you're asking for. And so if you're looping through 100,000 records
right.
and 5-6 fields, or 5-6 objects, JSON elements in each of those things, and it's scanning a 10 megabyte blob every single time, it's just not going to go over well. So the simple solution that I imagine some of you are saying, well, just paginate the response. Don't ask for everything at once. The problem with that, and we did try that, the problem is the sync still takes a really long time. Because by the time you make the batches small enough to where you're not running into these issues with the JSON functions, the number of API calls you're having to make drastically increases. Because we still need all of the data. We don't just need some, we still need all of it right now. And so you end up waiting for FileMaker to make, depending on which table you're talking to, 30 to 100 data API calls. And the data API is just not performant enough to turn around responses that quickly. As a user sitting there trying to sync these 6 figures worth of records. In part because a lot of those calls, the server, FileMaker server, is doing the same query and then giving you page 31. And then it does the same query again, but page 32. And then the same query again and page 33. Right? And it is just not fast enough. So the solution was don't use the data API.
Thank you for coming today.
And instead use OData. And the reason for this is OData has the option to return the result as XML.
Old school.
So some of you may see where this is going. And with that XML response, we could write a custom XSLT file to translate and interpret that XML structure, and then use FileMaker's native import function, mapping that XML with the XSLT, and just import the records that way. And the result of that was we were able to import roughly 100,000 records in about 25 seconds, which is, I mean, that's a huge, yeah. And
Slight improvement.
I mean, it's still not something that, you know, I imagine many of us in the apps that we have on our phone, and you click sync on something, gosh, 25 seconds seems like a long time. But for this business use case, when, you know, for what they're going to be doing with the frequency that they're going to be doing it, I mean, 25 seconds is perfectly acceptable for this use case. I mean,
On a native app, you've got background threads, which don't exist.
Right.
FileMaker, which was another huge consideration. So getting that number as small as possible.
Yeah, and I mean, and gosh, to write in that many records that quickly, I think is pretty cool. The next thing was writing data back to the host, right? So the local file now has all the information that it needs, but they're going to be making approval decisions or denials of these payments. Those need to be sent back to the server. So there were two instances where we were writing data back to the server. The first was in checking out records. So in an effort to reduce the likelihood of sync conflicts or someone modifying the record on the host while the local app still had it, we had a checked out flag in these records to just mark them as, hey, the app has these. So that way we could prevent users on the host from modifying them. So we tried Data API to mark that flag in those records, and is just, again, not fast enough. We tried the same thing with OData. Again, painfully slow, not fast enough. And in part, that's because, you know, if we are checking out, you know, in the worst case scenario, 10,000 expense lines for the week, that is 10,000 records that need to be updated on the FileMaker side. So, you know, if you build a post request or a put request of that has 10,000 objects in it, like that's one, it's going to take a little while to build that object, and then two, it's going to take a little while for the Data API or FileMaker server in some other way to process through that giant response. So instead, what we did was we wrote a FileMaker script that runs on server, and OData just calls that FileMaker script. And it's a simple script. It goes to these expense lines, does a find, and then a replace field contents that says all of these are checked out. And in our case, that worked because the things that were being checked out are always based on status. So the expense lines get put in status 3.4, which is they're ready for review. And that's the GET request that the app does. Give me everything that is 3.4. This find request that the FileMaker script does can just look for things that are 3.4 and mark those as checked out because those are the records that would have just been received. That was super performant. I mean, FileMaker server can do that super quick because that's just how it's using the tools that are built into FileMaker at a deep level. The second instance of writing data back was syncing those approval decisions back to the server on a line-by-line basis. So again, we tried the Data API, OData batching approach, but we had the same performance issues. So the solution that we settled on, some of you may have an idea based off of the prior solution that we did, is in the local app, we produced the found set of records that were ready to be synced back. We exported that found set as XML. And then we wrote that XML file back to the server just into a container field. So we created a table called sync results. And on sending these decisions back, we create a new record in that sync results table, take that XML file that the local app created, and just stick it in that container field. So we're only having to edit one record rather than thousands of records. And then run a server-side FileMaker script that goes to that record, takes the XML in that container field, imports it into the right place, into the host system, and does all the processing that it needs to do.
Matching keys and whatnot.
Yeah, matching keys, identifying sync conflicts, et cetera. So all the local app has to do is deposit the XML onto the server, and then it's done. It can go about its business. So some advantages of that: we have a record of all of the data changes that have been made with each sync request. So rather than just looking at what are the current values in these expense line records, we can read through that XML and see what did, on this sync request, what did they push to the server? And on this one, what did they push? Which is great for debugging, or if we need to rerun something, or something went sideways, whatever the case may be. We have a record of exactly what they pushed in. It's also a whole lot faster, which I said. And then the sync conflicts are dealt with by the bookkeeping department on the host side rather than on the client side. And in a number of cases, in this situation, that made sense, because if, for instance, you have an expense that, for whatever reason, already got paid, but management in the local app said, decline this expense, and then they sync their decision back. Well, you can want to decline it all you want, but that money's already gone out the door. So there's nothing like in the local app management can do about that. Bookkeeping needs to, figure out how to resolve that best on their end to, make a correction or a accounting entry or whatever the case may be. They can handle all that manually. Now, there were a few gotchas, and so I kind of want to talk through some of those gotchas and how we went about handling those. The first is on improving sync performance. So, as stated previously, is a very large number of records, and we don't need all of those every time, right? Once we've pulled in, maybe. Once we've pulled in those 30,000 payee records, for instance, we don't need to pull those in again unless new ones are added or maybe the name's changed or something like that. So, and this is actually Brian's idea, in all of the tables that we're pulling from, we added a UTC field. There's a few benefits to that. One, it's a number, not a timestamp, so it'll be faster to do comparison operators against. But also, it doesn't care about time zone. And so if you have a local app that technically could be in any time zone, and the local app, when it makes its API requests, when it makes its GET requests, it tells the server, give me everything that is modified since the last time that I synced. Normally in a hosted solution, you could just say, well, since the last sync timestamp could be based on the host's timestamp. This is a local file. It doesn't know anything about the host timestamp. So using UTC just solves all of those time zone issues. Then there was the niggly situation of, well, what happens when on the host side, some records are deleted? For various good reasons, there's always edge cases where, maybe an expense needs to be pulled back from review and then stuff's edited or deleted, whatever the case may be. So what we did was we tweaked some of the scripting in the host solution, and before we deleted these records, we logged the IDs and then deleted them. And then the local app, one of the things it pulls in is that list of IDs that have been deleted. Then it goes and it finds its local copies of those records and deletes it from the local copy. So that way we can keep those data sets in parity. Identifying sync conflicts, I already mentioned a little bit before, that we have scripting on the host server that identifies those and determines if this particular conflict is one that we actually care about. So, for instance, if an expense is paid, right, it has a status of paid, and the approver says, my decision is to approve that expense. Well, approved and paid are different statuses, but they really kind of mean the same thing, right? Approved is saying, I'm willing for this to be paid. If it's already paid, okay. Like, it's not a conflict we care about. As where if they want to approve it, but somebody else has already declined it, that is a conflict. And so we built a simple interface for the bookkeeping department that elevates these sync conflicts and shows them, here's what it is, here's what the app approver said. You make your decision on how you want to handle this. And then we added what I called an escape hatch sync option. So the main sync button only pulls things that have been updated since the last sync. But there's always the possibility, particularly since this is a bookkeeping-centric solution where numbers are kind of important, and the accuracy of numbers is kind of important, that maybe things get out of alignment and the local app has more data than it should or doesn't have all the data that it should, and basically the totals that the local app is showing is different from what the host is showing.
Loses connectivity in the middle of a sync.
Yeah, who knows? Like, all sorts of things might go sideways. So even though we're pretty confident that we plugged all the possible holes and that the numbers shouldn't get out of alignment, if they do, there needs to be some fallback option rather than just saying, oh gosh, I guess the numbers are just wrong. You're going to have to throw your copy of the app away and start with a fresh copy. So the escape hatch option goes through the local app, truncates all the tables, and re-imports everything from scratch. So that way it resets everything to the correct baseline. And that's just kind of as a backup. And hopefully they won't actually need to use that. Yeah, so Heather was saying if one person has been doing the approvals and then they go on vacation and the somebody else who kind of takes their responsibilities while they're on vacation hasn't been approving stuff for 3 or 4 weeks, that might be a situation where it's probably just safer to reset all of the data in that second user's application just to make sure that they're starting from a clean baseline. The next kind of big gotcha was security. So this is a local app which can exist and be used outside of the customer's network, which means we don't really have control over who gains access to the file. Obviously, we control who gains initial access to the file, who can download it and access it. But after that, if someone steals that person's laptop or some other way gains unauthorized access to the file, we don't know that. It's a local file, and this file has PII in it. It's mainly just names. But still, it's PII. So the local file is still encrypted, which means every time they open the file, they have to enter the encryption key. And then there's username, password requirements. What we did do to make the entering in the encryption key a little bit easier was we made the encryption key something that they could memorize. So that way they don't just have a text document with the encryption key sitting on their desktop, because that's not very secure. The encryption key is something that they can memorize, hopefully like their password. And also super importantly, the app does not talk directly to the databases, either the FileMaker databases or the MySQL databases. Instead, we're leveraging a gateway as kind of the middleman. And so the local app talks to the gateway. It can authenticate to the gateway, and then the gateway does the business of authenticating to the 2 host servers, the MySQL and FileMaker. So the local app doesn't know where the host servers are, doesn't know what they're called, doesn't know anything like that. Again, so that if someone gained unauthorized access to this file, there's very little that they could actually do.
Yeah, having the data API or our data running, just live to anybody out on if you can reach it, other people can reach it. So you definitely want to consider some kind of a gateway and something in the middle.
Yeah, definitely. And then on that gateway, we only lit up or allowed the required OData and API routes needed for the app. So if someone gained unauthorized access and was able to talk to the gateway and they put in some other route to try to do something nefarious, the gateway will just return an error and say, I don't know what you're talking about. That's not a valid request. So we're kind of throttling it and limiting it there. Also, the gateway itself is behind the firewall, which means that the app can only be synced if they are inside the network behind the firewall, which, for this business case makes perfect sense. So even to talk to the gateway that does, that talks to the servers, you still have to be inside the network. Yeah, so the gateway kind of provides a single plug that we could pull if someone somehow gained unauthorized access. We can just pull that, and then no version of this local app is able to talk to anything. It is a local app, so there are no external accounts. Our customer, for their main system, uses AD, so they authenticate with their AD accounts into FileMaker. That is not the case here. They are only, there's a small set of local FileMaker accounts that we put in the file. And the account that OData uses to authenticate into the FileMaker server is a special FileMaker account and privilege set that we created just for this app. And that privilege set has very limited privileges. So it can only it only has read access to like 5 or 6 tables, yep. And it only has write access to, I think, 2 tables.
Yep.
So even if someone gets through all of these other security measures, by the way, the local app doesn't know what account it's authenticating with. The gateway knows what account it's authenticating with. But even at that, there's very limited access into the system. With that, those gotchas, I'm going to hand it over to Brian, because Brian did most of the work on the actual sync engine itself. And if you'll notice, his forehead is a little flatter from all the walls he was banging it into. And there were a number of hard-won learnings and things about I think Data API and OData and some other things that I'd love for Brian to share.
Yeah, you'll notice the gotchas slide in the deck was extensive because there are so many gotchas that he mentioned. But just in general, you've got a user. This is not something that's just on a LAN somewhere in an office. It's you've got a remote user out in the field, and there's just so many considerations that you have to be aware of. It's one of the reasons that you shouldn't do sync unless you just really have to. There's so many things to worry about. So first of all, sync is hard. Sync is also not fetch. It's not fetching records. It's not posting records. It's certainly not the year 2000 where you have somebody out in the field who comes back to the office and then hard docks a device to sync. A lot of people have smart devices. They've got iPads, they've got iPhones, and things. So there's this expectation for apps to have all the data that they need at all times, whether that's just automatic syncing in the background. What if I lose my internet connection? The user should be able to at least see the data that they need to use, and then work within the app, make changes, make updates, and then have all that stuff just queued. Because they may not have connectivity when they go to push all those changes. So there's a lot of things to worry about. Data collisions. You've got things in the data API. There's a mod ID value that if you are using the data API, you can send your post can include that mod ID value, and that is a number that it just tracks a number of changes. And so if someone has fetched data, maybe they didn't work on it until later that day. When they go to push those changes back, maybe the data back on the server is different, right? And so you don't want people pushing data. Maybe they would make a different decision with the updated data. And so you don't want people out in the field pushing things and overwriting or not being aware of updated records back in the office. But we handled that with with the file import for the XML. We use matching IDs for that. We use the record locking after the records have been fetched. So basically, the general idea is that sync is hard, but it's worth it. If you're able to do it, it opens up a level of functionality that FileMaker's not really known for. We've got FileMaker Go, and that can get you by for some very, very simple situations. But anybody with a corporate solution is is going to have expectations based on other apps that they're used to using out in the field. So as far as Steve mentioned this earlier, originally this was going to be a native app. If anybody here is built for Android or for iOS, you've got dozens of frameworks, for networking and sync. The whole idea of a mobile device is that you can do these things. So there's a lot of built-in support. Background threads, background fetches, handling conflicts, whether records have been updated or not, which record's going to win, if the updated record out in the field is going to win, if the one on the server is supposed to win, if the two records are supposed to be merged. There's all kinds of things built into iOS. You can throw 100,000 object JSON array at iOS, and Codable, the protocol Codable will just rifle through that in seconds. It's not going to do the FileMaker thing where it's going to read in the entire JSON array every iteration of a loop. And prior to coming to Harmonic, I did a lot of iOS development, native with sync, offline use. And so initially I was really excited, but our client decided that they didn't want to go the native app route. So I immediately was concerned because I had not done any kind of scale like this for FileMaker, certainly not out in the field. So I wasn't even sure I knew enough about FileMaker to see if I could wrestle it into doing this project. Had it been somebody when I was out freelancing doing native apps, it would have been a non-issue really because of all that extra built-in support. One thing I wanted to cover, we didn't actually use OData has something called batches. The data API does not have batches, for starters. So every request that you make in the data API is just going to be a one-off. Every record's going to have a request. You can send portal data, but that's not really the same. One thing we considered about halfway through this whole process was, once we decided on OData, was, hey, it does batches. This is great. So maybe we can just put all of our requests into a batch. Which Eric mentioned ends up being a horrible idea because you're talking about tens of thousands of records, and batches are really not designed for that. They're more for things like a transaction, like an online shopping cart, for instance. You might have 15 items in your cart, and then when you go to checkout, all of the items in your cart could be sent as a batch, for instance, something like that. Certainly not for your 80,000 records at a time. And so there, even though we didn't end up deciding to use batches, I wanted to show you, because I spent a lot of time going through trying to get that to work. But I discovered some things that were, it just took a lot of effort, a lot of internal office help from Eric, from Steve, from a bunch of friends on Slack, to get batches to work at all at any size. So I wanted to go ahead and share what I learned with that, because some of you who have used OData or might be considering it with a smaller record set, where batches would apply, I wanted to go ahead and show basically how to construct that and how those work. I'm just going to show you three things. I'm going to show you the differences in the insert from URL call. I'm going to show you what a OData batch data payload actually looks like, and then how to actually construct that, because it's not really what it looks like on the surface. And so everybody here is probably familiar, I'm sure, with insert from URL. It's been around a long time. It's how we get things from the web and send them out. This looks largely the same as what you're used to. But the things I want to point out here are, you've got your path for your OData call, your host, your database, and then at the end of the path, you've got this $batch, right? That is not a variable. If you've read the OData Claris documentation, you might know this already. It is a detail that's sort of buried in the docs. My initial take on it when I was trying to write the path was, oh, that's a variable. So if you use a variable there, then none of this works. It's got to be $batch. It's a parameter. So That's the first gotcha for that. The rest of this, it's a post request. Normally, when you're posting a data payload from the data API or OData, you're almost always passing JSON. There's a nice architecture to it. Most people here know how to write it and read it. And if you go to the OData official documentation, not the Claris docs, but the OData official, the .org website, you'll see in their documentation, here's how you send a batch, and then they'll provide this JSON example. But the Claris implementation of OData for batches does not use JSON. It uses a different content type called multi-part mixed, which is a little lesser known content type, but it's got some very particular things about it that you need to be aware of that I was not. You've also got something called a boundary, which I'll show you in the next example. You've got a user and a password value, and then at the end for the actual the data payload, what a lot of you are probably used to doing here is doing a D flag, not data binary, but just D at $data. That's when you're sending a JSON payload. That's basically how you do that. That's the shorthand version that a lot of people are familiar with. It turns out that when you're using multi-part mixed, because you're not sending JSON, if you send just a D at $data, what it's going to do is it's going to alter some of the white space and return characters and things like that, which actually breaks the multi-part mixed payload. So I'm going to show you that in just a second. That looks like the actual payload value is this right here. There's some structure that's obvious at a glance, but it's not exactly what it seems here. The first thing is you've got a boundary value. And so this is a way of just like demarking the request, each object in the request. So this particular example has two payloads. It ends right here. The next object or payload starts here, so it's got its own boundary. And then at the end, you've got a closing boundary that just defines the actual payload, because you're not using curly braces or square brackets for a JSON payload. None of this is defined. It's just simple text. It's plain text. So you structure this with a boundary tag. This looks like a regular path here. The thing I wanted to point out here is that when you're using OData, let me back up. When you're using the data API, everything is record ID based. So if you want to delete a record, you need to pass the record ID. If you want to update a record, you need to pass the record ID. And that's the only way that you can reference a record with the data API. One of the nice things about OData is that you can pass it anything that is unique as a key. So you've obviously got keys in your relationships, but if you have other fields where you've gone into the field setup under the validation and have selected unique validation, anything that's got that selected, turned on, is a candidate for a key. So when you do your OData request, you can pass any of those values. Sometimes those are more useful if they're, if it's a value that's not like a UUID or something that's more, a little more useful to read and reason about. So that's a nice benefit of OData, that you can send a request using any of those unique values. Every request in the batch has a content length, and FileMaker Server is going to look at this content length value, and if it's wrong, your batch request is going to fail. So what the content length is the length of this JSON, including any spaces that might be in there, including the braces, including the quotes, end to end is the content length. So that's got to be accurate. You can calc that, of course, in your scripting. So you get down to the second the second request in the batch. And these batches don't need to have, they don't all need to be the same operation. These are both patches. These are 2 record updates. But you can have a batch where I'm deleting 5 records, I'm adding 2 new records, and I'm updating 15 records. And they can all be part of the same batch. So that's, it's nice that you don't have to group them that way. You can have a whole order of operations happen at once. So this is what it looks like. These look like regular just returns, carriage returns, a space, and a carriage return after each line. These are not really character returns or carriage returns. These are, this is also part of the multi-part form, or multi-part mixed rather, format. It's governed by boundaries, it's governed by white space and line endings. And so what you need to do when you create these payloads is you need to, they need to be what they call a carriage return line feed character, which some of you are maybe familiar with. If you're not, the carriage return is character 13, line feed or new line is character 10. You need both. You can't use one or the other. It looks like you're just using a carriage return or a line feed here, but at the end of each of these lines is a carriage return line feed. If that's not in there, your batch will fail. And so you might be thinking about, how do I construct this then? You don't just want to type it out visually because that's obviously not going to work. And so what I've got here is I just have a while or an example of a while that I was looking at when we were going to do the syncing back, sending of updates. So I've got a while loop that builds this, correctly builds this data payload. And so at the top of the while, I'm just getting a list of all the IDs, all the UUIDs in this case, for the records that have changes to be sent. And then I'm looping through those IDs. And for each of those, I've got a JSON payload, and then I've got a return delimited block. I've just got a list, just a list function. And list function only does a carriage return at the end, right? It's return delimited. And that doesn't really work for a multi-part mixed. But in order to create this block, I typed it out the way it would be, the way it's visually presented. And then at the end, in the result of the while, I just substitute out the normal carriage returns in a list, and I substitute those with the carriage return line feed. And then I tack on the closing boundary tag. And that gets me this. Taylor's asking if the carriage return line feed has to be in that particular order. I believe it does, but I am not 100% sure on that. Everywhere it's notated, it's CRLF. So my assumption is that it's got to be in that order. But you for sure need both of them. You can't do 2 returns. You can't do 2 new two new lines. So one of the big frustrations with this was that it took a long time to figure out multi-part mix to get the data payload right, and then it turns out that we couldn't use it anyway. And so I didn't want that these lessons to go unheard by other people. I even when I hit up my friends in Slack, with questions about this, a lot of people were just in the same predicament I was. I don't know how to do that. Or here's what I think it needs to be, but none of that was working. So shout out to my friends out on Slack that helped with the multi-part. OData has been around a really long time now. Came out 2007. It's at version, I think 4.01, I think is the official newest release anyway. And it's awesome. Claris started supporting OData a few years ago. So what you'll find if you venture into the OData space and get comfortable just writing simple queries. I'm going to fetch from a single table. I just need a handful of fields, nothing related, no related data. Once you get beyond that, though, you're going to need help constructing your URLs for the OData call, which can be confusing. The syntax is it's all got to be URL encoded, and you've got parentheses and single quotes and escaping characters is can be complicated. So you might find yourself on the OData documentation site, which is going to have 18 years worth of of feature documentation. And if you go through those and just start trying those out, what you'll find is a lot of them aren't going to work. There are features such as in the documentation, the official docs, you've got for the batches, they show a JSON payload, which you cannot use with the Claris implementation. It's got to be multi-part mixed. You've got what they call an in statement, where you're filtering, you're selecting and filtering records to come back with an in statement, kind of like a SQL in. And it turns out you can't use that either in Claris's OData. So there's a lot of things in there that aren't that are part of the OData spec that are not supported yet by Claris. So just be careful as you go start Googling questions. How do I do this? How do I do that? You're going to see a lot of things that just don't work in the Claris space. So just be aware that it's best to stick to the official FileMaker documentation.
One thing that I've done a lot, I like the way you did the XML things, but a lot of times that I'm moving either batch data or large data, I will make a data API call, but I'll run a script and I'll save it in a container field, and then I'll read the container field back.
Right.
Which is a little bit kind of what you're doing. A lot of times, my solutions are often on a PC or a Mac, so I've also found using Monkey Bread software plugins great if you're on that, but if you're on a iOS device, obviously, their functions are more complicated but more powerful and performant on it. And I also want to know, did you guys ever consider something like WorldSync or pros and cons to doing that versus spinning your own kind of things?
What did you call the other service?
WorldSync from 360works?
Oh, I'm not aware of that, actually.
Oh, okay.
No firsthand experience with it anyway.
Okay, those are my comments. Great, guys. Yeah. I love it. Learned some things.
Well, one thing I want to call out that we learned with getting XML back from OData is I think this is a bug in Claris's implementation of OData in the XML response, is we found that there was an XLS namespace declaration at the top of the XML that made the whole thing invalid XML. So we were unable to parse it in. So what we had to do was get the response back and do a substitute for that particular invalid namespace declaration and remove it, and then import the XML, and it all worked. So that was several hours of frustration.
Headbanging did commence at that point.
Yeah.
Yes.
So I know that one of the things that you mentioned with OData as a benefit over, say, Data API was the ability to use essentially real information, potentially customer-facing or user-facing data, as long as it's unique, as the key. So I can see how that would be beneficial. Can you call out any other benefits to OData? I mean, I think the one that I've heard bandied around our shop is the fact that unlike the Data API, you don't have to have a session model, session token model.
Sure.
Is there anything else you would call out?
We could do a whole session on the benefits of OData compared to the Data API. Frankly, there's for starters, Steve mentioned the session tokens. In a Data API call, you've got to send an initial request with a user and a password to get a token back, and then use that token value in subsequent calls. So you've always got this, back and forth happening. Now the Data API tokens will stay alive for at least 15 minutes, so you can keep using the same token. But it can be a real hassle to just the extra round trip, for is this a valid token, or give me a new one if it's not, before you can even get started transferring data. So that's The OData calls you pass the user and password value along with the request. So there's no token that can expire, that needs to be validated or anything. The second, probably biggest benefit that I saw that we used in this is that the data API is layout. Everything's layout based. So if you've got fields that you need to request, they need to be on a layout or you're not going to get them back. Which means you're going to clutter your graph with layouts just for mobile users and things. With OData, you're talking to the parent table. It doesn't even need a TO on the graph. You can just talk to the base table. If you need to fetch related data, you don't even need a relationship to the second table. You can create that relationship as part of the request and get back information without having to pollute your graph or make new relationships or anything. You can just do all that dynamically, which is awesome. Lots of benefits to OData.
Hi, Heather here, for anyone
Hi, I
who
know
can't
you.
see me and doesn't know me. I just wanted to make a comment in response to Taylor's question about had we considered WorldSync. We have used this in the past. It predates both Brian and Eric's arrivals at Harmonic, but we had a lot of experience actually with tools like that. We used WorldSync specifically in a prior version, life, name, etc. We had, in the end, a very good experience, but it was there was some. I'm sure it's easier now, but it was a steep learning curve to use a tool like that.
Yeah.
I don't know that it would have been particularly appropriate for this solution. We used it to sync to servers. So what we were actually keeping in real-time sync, or close to real-time as possible, were two networks, two instances of the same solution hosted on different continents. And for this, it worked very well once it was set up, but it was really intended to be a server-side sync solution.
Right.
And I'm sure that there must be, I haven't had to do this with it, but I'm sure there's a way to do that with a local copy. But I think, as I think through the use cases, I'm not sure that it may have worked as well to have real-time sync, where one of the things that we have in this solution is in the conflict resolution is two different people making different decisions looking at the same data. And if it were real-time sync, you wouldn't have those two different opinions to look at. But other than that, I'm sure that there's a way to do it, but that really wasn't something we thought about because we tend to think of it more as a server-to-server syncing solution, and for that it worked incredibly well.
Yeah, I think there's some. I'm not familiar with WorldSync, but back when I was when I started doing iOS development, I was looking for ways of using, building iOS apps with the FileMaker backend using the Data API or something like that. But there's something called MirrorSync. There's GoSync, I think, that might still exist. And then there's WorldSync, and there's maybe a couple others that I'm not aware of, but. Most of what I looked up, this is years ago, was it would make sync easier. It would handle things like conflicts, better. But underneath the hood, it just basically it abstracted away all of the sheer volume of records being created and updated and tracked. And so I think for what we were doing with just the number of records, I don't know that any of the sync sort of products that I've seen out in the wild that I'm familiar with anyway would have, if I had firsthand experience with it, I might have attempted to use that or give it a shot and see how it worked. But I think what we ended up with the XML, sending all the changes in an XML file and parsing that on the arrival back on the server, ended up allowing us to do something that, frankly, I didn't think FileMaker was going to be able to do at all for this project. And it's a project that I would have passed on probably as an iOS developer if somebody wanted this in FileMaker. So kudos to Eric and everybody on our team, and even my friends out on the internet, that we were able to get this project delivered with the specs that were requested, and all the while, certainly at the beginning, wondering, can we even do this at all? So I was happy to to find out that we could, and we built a really good app.
We're basically at time, but I think we have time for maybe one more question. Did somebody from the teams want to post a question? Josh?
Josh Willing. Hey, yeah, sorry, this might be too big a question to ask at the end. But I was wondering what kind of work you guys put into doing like database migrations, because if you have an offline solution, you have to kind of keep it in sync with the hosted solution. And sorry if you talked about that already and I missed it. I was off at the beginning of the meeting.
We just did one of those yesterday on the build, I believe. You want to address that?
Yeah, I mean, we've done considerable amount of work. Actually, with this same client, we do regular migrations with their production system on a monthly basis. Pushing, deploying new code. I think why we, at least in this particular case, why we didn't go a migration route is because we really only needed a limited set of the data. So, for instance, the files that we'd be pulling data from, some of these tables are 4 million records, and we only need 2,000 of them. And then they're maybe 100 columns wide, and we only need 3 of them. So I think a migration route just ends up bringing in so much more data than we actually need, which then has performance implications across the board.
What about like schema migrations for the offline file? Because like say your schema changes, you're using OData to talk to the hosted file instead. Like you force a sync before you, and then deploy a new local file, and then it can just pick up where it left off, or is there some sort of do you version the API on the server somehow? The old file can talk to the new one on the server before it gets a new version, or is that just beyond the scope of the project?
It just got delivered not long ago, so that's not really something that's. And we've discussed, versioning of the app and just in general, and how to deliver that, the best way. But we should probably have some meetings on that, on the schema changes. But
yeah, I mean, I think
different ways to go about
how
that.
I would answer that is for the things that this application is accomplishing, the schema for that is pretty nailed down and extremely unlikely to change. But we do have a kind of a delivery mechanism for if there are updates to the local app. Or to the API, something in that environment that needs to change. They do have a way to basically go into the hosted solution and download the latest version of that local app, and because the user base is so small and the frequency of app update releases is expected to be very, very rare. Because we're talking about like 3 users who might be using this app to approve things. So the solution that we chose was delete the local copy of the app that you have and download the new one. That was from we could have engineered something much more clever, but it wouldn't have really been cost effective to do so in this case.
That's can be one of the arguments for a native app in some cases, like for iOS. The persistence layer for iOS apps is called core data usually. So it's what allows the app to work offline. And you've got support built into core data for versioning. And so if you need to change the name of a field, you need to add a new field, you need to delete a field, anything like that, or change the behavior or attributes of those. There's lots of support inside of core data for stuff like that. So my thought is that we'll probably, if and when we get to that point, I'll probably, revisit that and see if there's a FileMaker-y way of implementing, a data migration scheme, because it's something that I've done a lot of, just not in FileMaker for a mobile app. But probably a lot of good ideas in core data we can borrow for that.
All right. Well, thanks again for everyone's attendance and time today. Thank you, Eric. Thank you, Brian. Yeah. Great presentation. We're going to direct everyone local up to our office for lunch. And like I said, make sure you ask these guys to see what the thing actually looks like, because it is pretty good looking. It's a pretty cool app. Thanks so much. We look forward to seeing you next month when Ralph will be presenting for us.